video because it only gives me the option of 720 at slow-mo mode. And so I got to figure out, because otherwise it just 34 minutes I think it'll take video. So anybody if they notice it goes dark, let me know. Thank you. Oh yeah, and I got to talk about what I meant by this. So you'll notice it'll always be this. Watch. P goes true, true, false, false. Q goes true, false, true, false. And do you see how I captured every possible thing? Right? I've captured every possible situation. There's only 4 situations, because how many options are there for P? 2. How many options for Q? 2. 2 times 2 is 4. So if I had 3 letters, how long would it be? PQR. 2 for P, 2 for Q, 2 for R. 2 times 2 times 2. 2 times 2 times 2. 8. It would be 8 long. That's in our future. We will have 3-letter problems. Right? Oh. So what do you think about and? And is very restrictive. So or, I always talked about back in the day when I was in college, we would go to the financial aid office. Nowadays you just go online and search this giant list of scholarships. But there's this giant book of scholarships, and you open it and you start reading. If you want $30,000 scholarship, yes, you must have this GPA. Yes, you must be a math major. Yes, you must want to go here. Yes, you must be a woman. Oh. I'm like, put that first. Put the most restricted thing first, please. Right? So you guys understand? So that would be ands, right? So and is very restrictive. It's difficult for an and to be true, because for an and to be true, every piece of it's got to be true. For an or to be true, you just need at least one to be true. That's why or's got a lot of trues for the outputs. Because the only way or could be false is if they are both false. I like it. We're going to make a little list of these sayings.
So it would be T, F, F, F.
I like it. The only way for and to be true is if they are both true, because it's very restrictive. So if the inputs are true, that's true, false, false, false. And real quick, I want to show you something that I hadn't thought about in a long time since I took that computer class. If I say true is like 1 and F and false is like 0, do you see how and is like multiply? 1 times 1 is 1. 1 times 0 is 0. 0 times 1 is 0. 0 times 0 is 0. Do you see that? It's kind of cool. No? You can see it? Okay. Or if you just like the English, if I say, in order for me to go, I have to collect $500 and I got to fix my truck. And I collect $500, but my truck doesn't get fixed, I ain't going. I had to get both of those things done, right? You guys kind of see? Yes? Okay. Maybe. All right, how are you feeling so far? So I really want you to see how this is a lot like an XY table. The beauty of it is there's only T's and F's. There's not 0, 1, 2, 3, up to 80 billion, up past that, right? There isn't. There's only T and F. Okay. All right, so now let's talk about a weirder one. Oh, well, I'm thinking about it. Before I put the I like turtles away. Who said that, by the way? Right, bring it with me. No, I'll have to show it to you next time. I have the, for those of you that did the survey, if you haven't done the survey, then still do it, but I'm about to say something that might change your answer. I can't believe I didn't bring it with me. So I printed it out, and the most picked random number is the one I would have predicted, which is 7. Human minds are not random. Always. Only one semester I had a class that picked the number 8 more than 7. It was just barely more than 7. I think the number 8 is lucky in a lot of cultures, right? But people think, when I say pick a random number, for some reason our brains go, I can't pick an even number. Everybody's going to pick an even number. I can't, maybe 3, 5. And for some reason, most of us gravitate to 7. If I said pick a number from 1 to 20, 17 would be the highest one, and 7 would be shortly after, and so forth. It's really strange. Always happens like that. One person said their favorite number was, I like turtles, and I am open. I always like to see who my smart asses are. The people, I think one person said something like 8.66 or something. Sometimes people say pi, because they didn't say pick a whole number, right? So I want to see who my smart asses are. But now I got a weird smart ass, and that makes things even more interesting. So
You know another reference?
No, is it from, not Dana Carvey's thing, is
No,
it?
it's a YouTube video. Well, it's some kid getting interviewed, and she's like asking him about his like costume, and that was his response.
Oh, and that was his only response?
Yeah.
Oh,
I
I've
think he
seen
was doing
that.
the
Okay,
question.
alright. I thought it was like Dana Carvey's weird ass movie.
That's what I thought.
Yeah.
Nah, you should go
I'm a
watch
turtle.
it.
Yeah.
I like turtles.
That's right, and then she turns away like, well,
Yeah, exactly.
well, I ain't getting nothing out of this. Alright, that's funny. I do remember that. Oh, man, it's funny. Alright, so that's and, or we talked about. Let's talk about if then. And this one always freaks people out, but ain't much I can say. I think, finally, I've been using this example forever, and the book now has the same example I use. And I don't know, it just makes sense. So the easiest way to explain how if-then works is to use a specific example. And the specific example that we would be excited about. If you make an A in this class, then you will get a car. Yeah. Now that's a statement that I've written on the board. I did not say that was true, so don't get all freaky. Maybe I'll give you a little Mattel car. Here you go. Yay. Tape it to your shoes. You can have homemade wheelies. Now watch this. Now this is where people get confused about if-then statements. So real quick. What are my two statements? Let's first break this down analytically, and then we'll talk about it in a more English sense. What are my two statements that I can give P and Q values for? What would P be? Yeah. You make an A in this class, that's P. Because the if-then will be part of the symbol, believe it or not. Just like and is made into a symbol, or is made into a symbol. They're not parts of the statements. You make an A in this class. So what would Q be? Yeah, you will get a car. Because a whole other layer to logic is if somebody understands logic really well, they can then become a lawyer or a politician, and they can say a series of statements that's logically true, that people accept at face value and don't think too much about, but what they actually mean is something very different from what it sounded like they said, right? I don't know if you understand what I just said. It's a very hard sentence to follow right there. I'm sorry. I'm not a politician or a lawyer. But if you understand logic, you can connect statements together in a way that makes what you said true, but it's not true in the way people think when they hear what you said. It's very evil. It's really evil. And that's why you want to know how to do this, so you can stop, you can say, whoa, shit, what the hell did you just say? Let me analyze that. Now, if you want to become evil, you can also use it for that. I can't guarantee that you won't turn to the evil side and become a politician or lawyer. Not that all politicians and lawyers are evil, by the way, but anyway. Now, watch this. When will you definitely get a car? If this is true, when will you definitely get a car? If you get an A. If you don't get a car, does it mean you didn't make an A? So look at it like a contract. If you make an A, then you will get a car. So if you don't hold up your end of the bargain, does that mean I can't hold up my end? So if somebody said, yeah, if you bring me, I'm asking for some help. You got $20, and I said, yeah, bring me a broom. I just need a broom. So I go around, I'm like, oh, I looked all over, man, I didn't find a broom. Could they still give me $20 if they wanted to? Would that make them a liar if they said, if you find me a broom, then I will give you $20? No, because the minute that's not true, I can do whatever the hell I want to. I'm only tied into doing something. If this is true, then I must do this. If this is not true, I can do whatever the hell I want to. Shit, I'm not the one with the restriction on me. Does See that? People don't get that. They get all confused. So if you make an A in this class, then you will get a car. If you don't get a car, what's the only thing I can say?
You didn't get an A.
Yeah, if you don't get a car, you cry, or maybe you won't. Maybe you'll bottle up inside and your emotions will explode later. All right, push it deep down inside. A little typo. Sorry. So if you don't get a car, what can I definitely say? You did not get an A. Then you did not get an A. But if you do get a car, I can't say shit. I don't know what happened. If you get a car, either you got an A, or whoever said this was feeling nice and they gave you a car anyway.
So on this, it would be true, true, and false, false.
Well, let's find out. So let's break this down. Now coming back. So how would I say this? What symbol is used for an if-then? This is called a conditional, by the way. Which kind of makes sense to call it a conditional, because on the condition that this happens, then this will happen, right? So we call it a conditional statement. We use this symbol, which sort of makes sense too. We use an arrow. If this, then this. Notice how the arrow points only in one direction. So let's see what this looks like as a truth table if we understand everything I just said about the mistakes people make with a statement. Okay. I like it. Most of you are awake. All right. So that would look like this, right? So, true, true. The only way you could possibly be angry or something is if what? The only way you could say I'm a liar is if what?
If you got an A, it's false.
Exactly. So that's the only place where what will happen here. It'll be false. That's where you're telling I'm a liar. The only way this statement could be false overall, the only way that I could be a liar is if you do get an A, but I didn't give you a car, right? That's the only way you could say I'm a liar. If you don't get an A and you get a car, I'm just nice. I'm not a liar. I'm just, all right, it's okay. You didn't fulfill it, but still, here's a car. Right? Do you understand? Yes?
So would that statement be like, if you got a car, then you may have gotten an
Don't bring the may in. We're not going to make this into a probability. Fuzzy, you don't want fuzzy logic. Fuzzy math. You know fuzzy math? Chaos theory. Jeff Goldblum, Jurassic Park. I know it's a long time ago, but you guys, they had video. It still exists. Putting the little water drop on his elbow. You remember that scene?
A?
Yes? No? Sort of? Watch the movie. Jeez. It holds up. It's before they had CGI, so it's good. So true, true. This is obviously true. Everybody's happy. You made an A, you got a car. Yay. This one, you made an A, but you didn't get a car, so that's false. That's the only way I'm a liar. These two, if the first part is false, the second part can do whatever the hell it wants to, because now the contract's broken. I can do whatever I want to. That's why these are still true. The only way a conditional can be false is if it's true implies false. That's another way to reference this one, is implies. It's a quick way to reference that. All right, how are we doing so far? We're just building things right now. I hope you understand. We're getting to the point, let me just show you an example, and I don't do this to freak you out. We're getting to the point where we can analyze this statement and see when it's true. We're going to do like algebra on that. I just freaked the hell out of all of you, but oh well, too bad. The thing I want you to realize is, if what I've just said makes sense, if what I've said so far about these little tables we made, if it makes sense, you're only ever comparing two things. In fact, when you do an algebra problem, if you really don't know it too well, you're only ever looking at two things, right? 2 minus 4. Hopefully everybody knows to start here. Right? You do 2 minus 4 and you get what? Negative 2. And then you do 7 plus 5. You actually physically can't. Does anybody believe they can? Can you guys multiply those all at once? Just at once. Just multiply them all at once. Hell no. Nobody can. How do you multiply these then? You look at these two and you get an answer. And you look at those two and you get an answer. Right? You only ever do 2 at once. Do you start to see what I'm saying? So with this big ass thing, I would first do a table for that. get answers, right? Do you guys follow what I'm saying? So you would start from the inside out. It's a lot like algebra, sort of. The nice thing is, all the variables could only have 2 values, not an infinite number of values. So let that part be nice. All right, maybe. Okay. So the last dude is called the biconditional. It's an if and only if. Which means it's more restrictive than the if-then. It's actually got to work both ways. Well, let's see, Jeff. It's more restrictive in a way, but then it comes out true more often. So we'll see why. No, you're right. It comes out true less often. So what do you think I use for a symbol if it has to go both ways? Double arrow. I like it. So not only does it have to work that way, it's also got to work that way, which is why it's going to end up having more falses in there. So how does this work? Normally we use this for definition. So I would say something like, what do you want to say, Jeff? A 4-sided figure. Let's see. I have a 4-sided figure. If and only if I have a quadrilateral. All right, that's exciting. Quadrilateral means 4-sided figure, so whoa, definition, big deal. Right? But if and only if is very restrictive. It means, it's sort of like saying, it's really difficult to find anything that's not a definition. Let's see if the book has some good examples. Probably not. No. Yeah. So if I did say, if I said, you will get a car if and only if you make an A. Now just take that in. Right? Maybe don't try to read what I wrote. You will get a car if and only if you make an A. How is that different from what I said earlier? If you make an A, then I'll get you a car.
Because if you don't get an A, you
won't get a car. See, that's now it's kind of putting us both in a contract. If you make an A, I'll get you a car. But also, if you make an A, I'll get you a car. If I get you a car, you must have made an A. So it's got to work both ways. And then if and only if makes it sound very restrictive, right? If and only if you make an A. So if you make a B, no. Whereas over here, if you make an A, then I'll get you a car. If you make a B, I could still get you a car. I wasn't under any contract. I could do whatever the hell I want to. Maybe. So what the hell does that mean as far as the truth table? Well, if you go with this symbol and you come off of this table, look, this way it works. When's the only time it doesn't work this way? It only doesn't work true implies false.
That's almost false.
So
So it's got to work the other way also. So if I do a biconditional, right? If I do a biconditional, and if I make sure people can see it, then it's got to work. So here's my true, true, false, false. Here's my true, false, true, false. Now I got everybody. So true, 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 true. Works both ways. So that's true. True doesn't work right off the bat. False, true is good. Doesn't work the other way. True, false. Damn. So that's another false. False, 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 false. That works both ways. So that's true. Bam. Maybe. I don't know. And the crowd goes, meh.
well, it makes sense.
Makes sense. Good. I like it. But that's like a point where you go, holy shit, that makes sense. That's not supposed to make sense. All right. So let's do one example, and then we'll head out a little early. What's that?
Sorry.
What'd you say? Share it. What'd you say?
I was giving gratitude and thanks.
Don't worry. When I'm nice to you, I'm nice to me too. So hey, don't forget that. So maybe just be nice for me.
Yeah, I make a truth table for that.
It's true when I want it to be. All right, let's see. So let's look at a more involved. First off, let's just do this. Let's do something very simple here. Let's try just throwing one negation in there. All right, so I'm gonna start with the longest way to do these. We're slowly gonna work in some shortcuts. I can't work in a shortcut until you see how the whole damn thing works. If you come up with your own shortcuts, cool. Just make sure I understand what the hell you're doing, right? So now watch this. So these are always going to be true, true, false, false, true, false, true, false. Yes, ma'am. Oh, thank you. Oh, yeah, that's right. Normally I have to push the screen to focus, and now I just take pictures every time I touch the screen. My old phone did it. So what would I put underneath this? What am I? I'm comparing not P and Q. I know what Q is, right? But what's not P? What would I put here for not P? Good. And I really want to make sure everybody understands. For this row, P is true, Q is true. So I know Q is true, so not P must be false. For this row, Q is false, not P must be, wait, P is true, so on this row, not P must be false. I like it. So if this is true, true, false, false, not P's got to be false, false, true, true. It's just the opposite of what P is. And again, it's just like an XY table. When you say 2, 3, 7, you say 7 right for you. Then that's, on this row, X is 2. On this row, X is 3. Right? That's what it meant. Maybe. And Q is just true, false, true, false. Now I can compare these two. I'm only ever comparing two values at once. And what is true about and? What's the statement I can say with it? And is only, it's the more restrictive one. So what does and need to be true? They both have to be true. So and is only true when they're both true. So look through and find where they're both true. Here, they're both true there. That's the only place. So everywhere else must be false. So that would be the answer. You've analyzed the statement. You know exactly when the statement is true and when it's false. It's only true if these were the inputs. Now we're going to bring in, some of you are going to realize, some of you are going to be like, oh shit, some of you are going to be like, oh good. We're going to bring in more English so you'll have a little more, something to stand on as to what the hell this means, right? So when we give these guys statements, when we give statements to these, you'll know, oh, that overall statement is only true if the first statement is false and the other statement was true. So you can parse out what somebody is saying. And not enough people in the world have that ability. So you don't sit there and analyze somebody's speech, right? You just kind of go, well, it sounds like you're saying this, all right, whatever. I don't know if you guys are understanding. All right, well, you better be, because I'm going to test you someday on this. Let's try one more. Did I say just one? Too bad for you guys. One more. Oh, come on. You're used to it by now, right? Let's try one without conditional. I want not Q implies P. So again, you can always do true, true, false, false. True, false, and then you captured everything. Oh, while I'm thinking about it, this is not a valid letter. So if you write that and I say, what did you write? And you say, well, what was the right answer? You know, that conversation won't go very far, right? So I do have that every now and again. And I'm like, don't know. So what do I do first to analyze this? What do I do? What's the one piece that I don't know yet? There's something up there that I don't know officially. I know what P is. I know what Q is. Everywhere.
So you don't know what not.
I don't know what not Q is. So what's not Q? False. True. False. True. So I'm just negating Q. And I can write P again if I want to. Some of you guys realize the first little shortcut is just to not rewrite P. But let me just do it. True, true, false, false. Because that's P, right? So now, what is it about the biconditional, the if then? It's only, who remembers? The if then, it's only It's only false
It's only false if the first person, if
if it's,
not done or not.
oh, I see. So try to take it away from too much English when you're trying to remember, because it's too long then. It's only false if true implies false. And don't worry, we're going to continuously say this. Next time I'm going to have a little handout that's going to have all these little statements. The more you remember these statements, the easier this is going to be, no matter how big it gets, because you're only ever looking at two things at once. So where's the only place where it's T implies F? Anywhere? The last one. T implies F. This is F implies T. That's fine. That's fine. That's fine. That's no good. So the only time the statement is false if both pieces of the statement were originally false. Okay, maybe some of you guys start to realize this is like algebra light. It's just different. So that's why it feels difficult. That's plenty, I think, for today. Don't forget, quiz this Wednesday, chapter 1. Okay.
It's gonna be loosely favored.
Say again?
It's gonna be loosely favored.
I'll make the quiz so you can write on it. My quizzes aren't that long, so I give you plenty of space. Thank you.